triangle, you have different parts of an isosceles triangle. The two connecting sides, or the two congruent sides, sorry, are the legs. So this part is a leg. This part is also a leg. The angle where the sides connect is called the vertex angle. We're not going to put that because it's not super important, but that's technically the vertex angle. The opposite side, the side opposite of the vertex angle, is called the base. So the base is always opposite of this. So this is your base. Your base is not always your bottom because your triangle can spin around. Sometimes your base will be to the side or above it. It's always opposite of where the congruent sides are connecting. What's up? I mean, I guess for them why, but like the idea is that you keep them. But if okay. Okay, the side opposite, the side opposite of the vertex angle is called the base. We already said that one. The angles, this is the important part. The angles along the base are called the base angles. What's important about an isosceles triangle, not only do these two sides are the same measurement, these angles are also the same measurement. So 2 and 3, the base angles are congruent to each other. So even if they are not marked in your picture, you can add it to your picture. So the isosceles triangle theorem basically states if two sides of a triangle are congruent, then the angles opposite of those sides are also congruent to each other. So for our example, we're going to say angle 2 is congruent to angle 3. And remember, congruent just means they're equal, they're the same. The opposite of that, or the converse, the opposite of this, is literally using common sense to say, well, if the two angles of the triangle are congruent, then I could say that the opposite sides are congruent. So if I only have the angles marked in the picture, that's the only thing that's given, I can use common sense and add in these little tick marks right here and right here. So you can work it one way and you can work it the other way. So everything's not always going to be marked. So we'll say AB is a side is congruent to CB. And then over here, they're taking isosceles triangles and then they're adding in a perpendicular bisector. So if you have a middle line, what this is doing, not only are the sides congruent, just like before we said, if the sides are congruent, I can also say that these angles are congruent right here and right here. And it's creating a 90-degree angle. So in this picture, they have the 90-degree angle. If I know the bases are congruent, I can still say that the angles are congruent. I can also add in that these sides are congruent. So I can kind of add in tick marks literally like everywhere. There you go. So as long as I know one of the sets are congruent, I can basically add in these other two things. If I know the angles are congruent, I can say the sides are congruent. If I know that the like sides are congruent, then I can say the base angles are congruent and vice versa. So we can kind of manipulate it. Remember, the square means 90 degrees perpendicular, and that's what the upside down capital T means. So let's do a couple problems. These should not be too bad. So QS bisects the vertex angle. So it's bisecting it. Notice I have this arc and this arc. That means they're congruent. I have to find the measure of angle RSQ. So if I start at R, go to S, go to Q, I'm talking about this little angle right here. So I'm putting a little X there because I'm trying to find him. Does anybody see where else I can put 31 in my picture? R, because it's isosceles. PQ and QR, yeah, okay, these are the same. This is 4, this is also 4. We could put that in our picture. Those are a length, that's why it's on the outside of the picture. With this middle line, what else could I add to my picture? On 90 degrees. So a little box. I could put a box over here and I could put a box over here. So you could look at this a bunch of different ways. I think the easiest way is to cover up one half of it. And now I'm looking at this little small triangle. From before break, how much does a triangle add to make? 180. So I could do 90 plus 31 plus something equals 180. You could do that in a calculator. You could write an equation. You don't need to write an equation. I'm okay. You guys are like honors kids. So like you can literally plug it into a calculator. What is the answer to this? 59. And it's a degree, it's inside the triangle. So sometimes you're going to be finding the length and sometimes you're going to be finding the degrees inside. If it's inside, they add to make 180. If it's the outside, it's talking about a length. So I need to figure out what PR is going to be. It's just 8. from P to R is this entire length. And just like last time, even though it doesn't say, because I know this is congruent, I can say that these two are congruent. So that's a total of 8. Easy peasy. Let's go to the next one. Number 2. So take a second using what we kind of just did. See if you could figure out the measure of angle DAC.
This is 24. That the line on the inside, the line on the outside.
That's the line from A to D is 24. Okay, so for DAC, if I'm talking about D to A to C, that's right here. So if I put a little X here, boop, boop. You should have at least been able to bring over your 67. Your 67 goes here because isosceles, notice your triangle's turning. So this is not 67, this side and this side are 67. And then you know that this is obviously 90 because the square. So did anybody figure out what that little angle is? Yeah, 23. So if you cover up the other triangle, you have 3 little angles that you're trying to use. So I have 90, 67, X. So the answer to this is 23. And if you don't get that, I will write the equation down. And then I'll just put the answer. But if you got it, you could just put the answer. That's okay. For BC, what is the length of B to C? 20. Good, because if this is 10, then this is 10, and then obviously add them together to represent the whole length, which is 20. And this is where the Pythagorean theorem comes into play. You want to find AC. AC is this hypotenuse, technically, of this triangle. So if I look, it's not an equilateral, so I know it's not 20. But if I look, I have a 10 here. I know that this is 24, and I don't know this. This is the hypotenuse of a right triangle. So if I were to like sketch this out, just so that way it's right side up, I have my 90 there. I know the bottom is 10. I know the height is 24. And I'm trying to find that. Does anybody know, would that be A, B, or C? That is C, because that is the hypotenuse. And then this is where we're going to bring in the Pythagorean theorem. Remember, A and B can go back and forth. It doesn't matter which one's A and B, as long as it's the legs. Hypotenuse always has to be C. So we're going to do A squared plus B squared equals C squared. So A, I'm just going to use 10 plus 24 squared equals C squared. And you will need a calculator because you're going to need to use your square root button. Or if you have your phone, you're going to have to turn it sideways, but you need to know where your square root button is. Well, no, I'm talking about like when we take the square root. 10 times 10 is 100, right? What's 100 plus 20? What's 24 squared? No, I think you added them and then squared it. You squared it, you didn't square root it. So 100 plus 576 is 676, obviously. And then you have to square root it. So you should not get bigger, you should get smaller. So if you use a calculator, you have to press shift square root. Do we remember doing this in middle school? No? Seriously? You've never seen the Pythagorean theorem?
I know I did.
Raise your hand if you don't remember ever seeing the Pythagorean theorem. Like, this is literally a foreign thing to you.
I remember it. I just don't remember.
Yeah, I know. But like, yeah, it's pre-algebra. Okay, well, okay. The Pythagorean theorem is, I mean, we're going to do it again, but like the Pythagorean theorem is, you're supposed to learn it in middle school. Like, I'm really not even supposed to cover it. But anyways, it's A squared plus B squared equals C squared. C squared, the most important part, is the hypotenuse. It's the longest side. It's opposite of 90 degree. So you square the numbers, 10 squared, 24 squared, add them, and then you square root it to get C. So what does this end up being? 20, 26? Yeah, I got 26. So C equals 26. So really AC is 26. So I'll just call it AC instead of rewriting it again. We're going to do it again. Okay. Okay, so take a second, look at number 3, see if you can move things around. Okay, so if you're having trouble setting up, we're gonna talk about it and then you guys can solve it. Since this is an isosceles triangle, does anybody see something that I could do? Something maybe I could move around, but I could maybe add to my picture? Okay, a right angle. So I know this is a right angle, right? Boop, boop. So I could add another square. Where else could I move something maybe? Good. So G is equal to B. So I could put 4x plus 9 also here. Perfect. Does anybody see what I can maybe do to help solve for X now? Because I have enough information technically. Yes, equal it to 180. You're not going to include the entire triangle. I mean, you could, but it would require a lot more work. If you look, there's technically 3 triangles in this picture. You have the big one, and then you have the 2 smaller ones. So if I just cover up this one, I still have a triangle, a singular triangle. I could do this plus B plus 90 equals 180. So it's kind of applying the stuff from before break. So I'm going to do this plus 90 equals 180. So 3x plus 4 plus the base angle, which is 4x plus 9, plus the square. People have been forgetting the square. Don't forget your square. Equals 180. And then I'm going to combine like terms and simplify. So take a second, try to combine like terms. These should always reduce down realistically to a 2-step equation. Okay, so when you combine your x's, 3x and 4x makes 7x. When I combine just my numbers, 4, 9, and 90 makes 103. So I have to minus 103 to both sides, and then I divide by 7, so x equals 11. How do we feel? So far, the problems that we've done so far have been adding to make 180. So let's change it up a little bit. So for number 4, it's the same thing. I have that little line in the middle. It's bisecting it. It says KQ. Oh, I'll zoom out just in case you're like copying that one. But KQ bisects the vertex angle, solve for X. So in this case, I have my angle bisector. This time I have this and this, so I can't move it anywhere because I know this and this, like they're the same anyways. This is right here and right here. I don't know anything about K. The only other thing I can really add to my picture is if I really wanted to put a little 90-degree here, but I don't know anything about K. So what could I do since I know it's an isosceles triangle? This is not adding to make 180. Set them equal. Who said that? Good. Set them equal to each other. Because it's isosceles, the angles are congruent. So I'm going to put an equal sign between them. So I could do 10x minus 7 equals 4x minus 1. Because isosceles triangle, I know the base angles are going to be the same measurement. So I could just equal them to each other. And then you could solve this different ways. So take a second. I'm going to move the 7. Move whatever you want. I don't really care. We're almost done. I feel like you guys don't need me to teach you how to do like solve the equations. It's like just setting up the equations, right? You guys are decent at solving. Yeah. Did we get one? Okay, good. Okay. The last two, these ones are huh? Yeah. In this case, you could use the same exact knowledge as what you used before. If I know that this and this are congruent, since it's a perpendicular bisector, I can then conclude that these two are congruent right here and right here. So I'm going to do the same exact thing. These are lengths. They're on the outside of the triangle. So I'm going to add in that piece of information. So not always are you going to be given what you need to know. You just need to know, okay, I can add this here. So those two sides are congruent. So I'm going to equal them to one another. So same way I set them up before, 7x minus 22 equals 4x plus 5. Add 22 to both sides. And then I'm going to subtract 4x to both sides. And then divide and you get 9. And then look at your picture for the last one and try to figure out, would I add to make 180 or should I set them equal to each other?
And then
Yeah. Yeah. Assume if they're giving you the same exact thing on the other triangle in the same exact location, they're going to be equal to each other versus like the other ones we were doing. We had a top piece and a bottom piece. Those are not the same. So I can't add those to make 180 or I can't add them to equal each other. Huh? Yeah. Yeah. But I mean, this one only gave you 2 measures. You got the 90, but you also get a, yeah, you got 4, you got this, and then you got the 90. But the same thing here, you got this, you got this, you got 90. So okay, then what are you talking about? Oh, yeah, yeah, yeah. So if like you have pieces, yes, if you have pieces for all 3 corners, it adds to make 180. If you have the same pieces on different triangles, they equal to each other. So for the last one, they're in the same spot, different triangles, so they're going to be equal to each other. So I'll say 8x minus 32 equals 3x plus 3. So add 32. Numbers go with numbers, always and forever. So I have 8x equals 3x plus 35. And then minus 3x to both sides. So 5x equals 35. I'm not moving too fast, am I? I'm like going at good speed. X equals 7.